In this video, I want to go over a few examples and try to determine the size of each one of these matrices. And while we're doing this, we'll also talk about a few special matrices, such as square matrices or the zero matrix, just to familiarize ourselves with a little bit of terminology. So in this first example, we have this matrix 2, 1, 0, -2, -9, -4, and then 3, 0, 2. This is a matrix, right? So remember, we can determine the size of a matrix by counting the number of rows and then the number of columns, right? And we usually refer to rows with n and then the columns with m. So we say a certain matrix is n by m size. Well, for this matrix, we have 1, 2, 3 rows, right? And we have 1, 2, 3 columns. So this matrix is a 3 by 3. And since n is equal to m, right, 3 is equal to 3, this is also called a square matrix. And that's simply because the number of rows equals the number of columns. So let's do another one. What if we have this matrix? 0, 1, 2, 4, 8, 16, and 32. Well, this one's a little bit strange, right? But let's just simply count the number of rows and count the number of columns. Let's start off with rows. We only have one row, right? The number of columns is 1, 2, 3, 4, 5, 6, 7. So the number of rows is equal to 1, and the number of columns is equal to 7. So this is a 1 by 7 matrix. And this is actually called this is a special matrix called a row matrix, or sometimes called a row vector. And we'll get into that later, but a row matrix or a row vector simply is a matrix that only has one row. And it can have, well, it should have more than one column, right? So some other examples of row matrices are 1 by 2, 1 by 77, 1 by 3 trillion, and 1 by 10, right? Each one of those matrices has only one row, but it has more than one column. Let's do our third one. What if we had this, E? And E is just the Euler's constant, so it's just a number, right? It's a constant number. Well, this matrix has one row and one column, so this is a 1 by 1 matrix. All right, so what if we had another matrix that was slightly bigger? 1, 3, 1, 2, 1, 6, and then 7, 6, 8, 0, 4, 6, 8, 2, 8, 4, 8, 2, and then 4, 9, -1, -2, 7, 7. What if we had this matrix? Well, let's count the number of rows. We have 1, 2, 3, 4, 5, 6 rows. We have 1, 2, 3, 4 columns. So the number of rows equals 6, and the number of columns equals 4. So this is a 6 by 4 matrix. Cool, so let's actually scroll down a little bit and do another example. What if we had 1, 2, 3, -2, 0, 1, 0, 4, 7. What if we had this matrix? Well, let's count the number of rows. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 rows and we have 1 column. So the number of rows equals 9 and the number of columns equals 1. So this is a 9 by 1 matrix. And this is actually a special matrix, sometimes referred to as the column matrix, or even sometimes called the column vector. And column matrices or column vectors always have only one column, but they can have more than one row. So some examples of column matrices are 100 by 1, right? 100 rows and only one column. 3,427 by 1, right? It has 3,427 rows, but it only has one column. And even 1 million by 1, right? 1 million by 1. It has 1,000,000 rows and only one column. So all of these are called column matrices or column vectors. Now let's scroll down a little bit more and let's take a look at this matrix. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Well, let's count the number of rows. We have 1, 2, 3, 4, 5 rows, and we have 1, 2, 3 columns. So row is equal to 5, and the number of columns is equal to 3. So this is a 5 by 3 matrix. But this is actually a pretty special matrix. And this is called a zero matrix. And a zero matrix is simply a matrix of any size that has all zeros for its elements. And this is also sometimes called a null matrix. And we'll get to zero matrices and null matrices a lot later in this course, but for now, at least you know what it is. And finally, if I scroll down, let's do one more example of a special matrix. Let's say we have the matrix 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and then 0, 0, 0, 1. This matrix right here. Well, let's count the number of rows, 1, 2, 3, 4, and the number of columns, 1, 2, 3, 4. So this is a 4 by 4 matrix, right? And this is also another special matrix called the identity matrix. Identity matrix. And an identity matrix is simply a square matrix, so the number of rows has to equal the number of columns, in which all of the diagonal terms, the main diagonal terms here, are all ones, and every other term in this matrix or element in this matrix is 0.